Okay, the physical properties of aldehyde and ketone. Physical properties. Physical property of aldehyde and ketone. Okay, so first physical property is that most of the aldehyde are liquid at room temperature. Most of the first about aldehyde first aldehyde. Most of the aldehyde, first point, most of the aldehyde are liquid at room temperature, except one, except formaldehyde, except formaldehyde. Formaldehyde is a gas. Formaldehyde is a gas. CHCHO. This is formaldehyde. Formaldehyde is a gas at room temperature. So why they are liquid at room temperature? Most of the aldehyde are liquid at room temperature because they have a strong force of attraction due to the presence of oxygen and hydrogen bond. That is why they are liquid at room temperature. Due to the presence of oxygen and hydrogen, they are liquid at room temperature because they have a strong force of attraction between them. Okay?
Yes.
Then if we talk about ketone, we are taking both the aldehyde and ketone together. Most of the ketone are colorless liquid. Yeah, also colorless liquid. They are colorless liquids with pleasant smell. With pleasant smell. The smell is very pleasant. Like that of fruiting, like that of fruit with pleasant smell. With pleasant smell. Okay. Whereas higher member are colorless solids. Higher members of ketone. Higher member of ketone are colorless solid. Colorless solid. Because still their force of attraction increases. Okay. And aromatic, I will talk about aromatic ketone. Aromatic ketone. They are colorless solid. They are solid with pleasant smell. Solid with pleasant smell. Solid with pleasant smell. With pleasant smell. Okay. Hello.
Hi.
Yes.
I just calling you from Japan.
Yes. Yes. Yes.
I hope it's the time to talk right now.
Yeah. Yeah.
Okay. The name of this student is, sorry, I think I might get the pronunciation wrong. Yuta.
Yotam. Yes.
Okay. So, I hope you understand the purpose, right?
Yotam is basically inactive, right? Because he has not renewed his classes. No, I have talked to the parents, so said that they will be reviewing after some time. Okay. Okay.
When we
Oh, 1 minute, I will talk. निखिलेश 5 मिनट वेट करो, ठीक है?
Yes, sir.
कॉल करता हूँ, ठीक है?
Yes.
5 मिनट वेट करो, ठीक?
Yes, sir.
Yeah. Most probably after before every class I interact with the parents because we basically talk to the I basically talk to the parents, call her about the classes and all the things. I think she is more satisfied because I have a conversation from his mother also that he is very much understanding. I have met her also. He is very much understanding about how the way I am teaching him. So he has reviewed because they are reviewing every month. Because your son is taking both classes, math also coding class. So I am taking math, but some other teacher is taking coding class. Okay. Okay, so I can see he has not activated both. So he takes every month, he takes 16 classes. From 2 times he has done that way. When I begin teaching here some, he has reviewed 2 times, and both the times he has always taken 8 classes, means 16 classes, out of which 8 classes are 8 classes of math and 8 classes of coding. Means every month he takes 8 classes of evolution. Yeah, he is good in that. He's good in that. But he is more often, he's good in class, but he is not functional. Means every time I have to shift his class because his mother asked me, because we have not over this time to shift it. So there is no time take. He used to shift the class every day, every week. Every week I have to shift the class. Excellent. He gets the concept very easily. He's like you. He is good in algebra, and he is also because from when I started taking class, he is doing algebra with me. So yeah. No, in algebra he is fine. If he has some queries, he always tries to ask me. Assessment he completes means he is not very because he is get disturbed by some question, but because he is average, but means not doing very fast, not very slowly. So accuracy his average score is 70-75%. So it is I am totally dependent on your phone because I asked questions using the chapters that we are doing in the class. We will continue here only in the Q&A. So no, he just asked me about algebra, so we have started doing algebra. After doing algebra, he wants to shift in another chapter. So he never talked to next chapter. We will algebra only. And one more study is there. I talked to her mother, that is Kashi. So I am in touch with him. So I for 2 days earlier, I have talked to her. So she said that he will be reviewing and he will be reviewing the class and let me know. Then today he wants to renew after some time, after 1 month. So talk to them and convince them to renew because I think he will be renewing, but there must be some financial issue or something that's why he is not renewing. The problem because they are very pleased with the human app, so they must be reviewing. Okay. No, student does not have it. She is in class in grade 3. I am in touch with her. She told me whenever she renews the classes, she will let me know. Message me then. No, everything you have asked me just that. So I have to do it. Okay, well, this is your number. Okay. Okay. मेंटल नहीं, आजकल इन लोगों ने बदल दिया वो जो भी अरे कहते हैं ये लोग क्या कहते हैं पहले जो रिन्यूअल के लिए जैसे कि जो हम रिन्यू नहीं करा रहा उनको कॉल करेंगे रिन्यूअल के लिए क्या प्रॉब्लम आ रही है तो कांटेक्ट करेंगे तो हमसे फीडबैक लेते हैं। अब जो मर्जी है उनकी हमारे से क्या मतलब। ओके ओके सॉरी निखिलेश आई हैव गॉट एन इंपॉर्टेंट कॉल दैट इज व्हाई आई एम नॉट एबल टू।
Yes, no problem.
So we are talking ketones. So now, so if we talk about the boiling point, if we talk about the boiling point, so aldehyde and ketones have both aldehyde and ketones both have high boiling point with respect to their hydrocarbon. They have high boiling point. Both have high boiling point. High boiling point with respect to their corresponding hydrocarbon. What do you understand by this, Nikhil? Corresponding hydrocarbon. Like if we talk about acetone, CS3CHO, and we talk about ketone, like CS3 and CO. CS. So that's how we can talk about CS3 or this is propanol and this is propanol. This is propanol and this is propanol. And their corresponding which hydrocarbon they have, they are made up of propane. Both their corresponding hydrocarbon is propane. So they have generally high melting point and boiling point, high melting point and boiling point to the corresponding propane. Okay, got it?
Yes, sir.
Got it, Nikhilesh? Got it?
Yes, sir.
Why it is so? Because propane is neutral. Propane has no charge. We are neutral. No charge. They have no charge. They are neutral. No charge. But propanol and propanone has dipole moment because they are positive and negative charges there due to the presence of oxygen group. So they have dipole moment. Dipole moment means they have positive and negative charge. Both the aldehyde and ketone both have dipole moment due to the presence of positive and negative charge due to the presence of oxygen. So oxygen has negative charge and carbon has positive charge. So both have dipole moment. Due to the presence of dipole moment in aldehyde and ketone, they are strong force of attraction between them. They have strong due to presence of dipole moment. They have a strong force of attraction between them. Strong force of attraction between them. Force of attraction between them. Attraction between them. So they are melting. So it is very difficult to boil them, because in boiling bonds are broken. Boil them. So their boiling point and both melting point are very high. Got it?
Yes, sir.
Written?
1 second, sir. Yes.
Okay. Talking about solubility, if we talk about solubility, third point, solubility. Solubility in water. Solubility in water. Solubility in water. The lower members of means 1 to 4 carbon atom. The lower members of aldehyde and ketone. The lower members of aldehyde and ketone. The lower members of aldehyde and ketone are soluble in water. Are soluble in water. Why they are soluble in water? As they are hydrocarbon. They are basically made of carbon atom. So they must not be soluble in water. But due to the presence of dipole moment of hydrogen, because they have dipole moment, they have positive negative charge, they can form hydrogen bond due to the presence of dipole moment or charge particles. They can form hydrogen bond with water. They can form hydrogen bond in water. Hydrogen bond with water. That is why they are soluble in water. That is why they are soluble in water. That is why they are soluble in water. Okay. But higher members, the solubility decreases. The solubility decreases. The solubility decreases as the number of carbon atoms increases. As the number of carbon atoms increases. Increases. Okay. Got it?
Yes, sir.
Can I rub this?
Yes, sir.
Now these are the physical properties. Now we come to the chemical properties. Chemical properties of aldehyde and ketone. Chemical properties of aldehyde and ketone. Okay. First, most of the aldehyde and ketones, very important. Aldehyde and ketone, aldehyde and ketone give addition reaction. Addition reaction. Why they give addition reaction? Because why they give addition reaction? Say so addition reaction means addition of some atom. And why they show addition reaction? Because of the presence of double bond. Because of the presence of double bond in them. Because they are double bond, they are very weak bond. So aldehyde, both the aldehyde and ketone have double bond. The aldehyde is CH, so it is H and double bond. And this is aldehyde. And this is your ketone. They also have double bond. So the new atoms are added to this double bond. So new atoms are added to this double bond. They are added to this double bond by breaking this. And the addition reaction is of which type? The addition reaction is of nucleophilic addition reaction. They show nucleophilic addition reaction. Nucleophilic addition reaction means nucleophile addition reaction means nucleophiles are added to the aldehyde and ketone. Okay, they say nucleophilic addition reaction, very important. Okay, so why nucleophilic addition reaction? Because if you see the structure here RCOOH, so it has low electronegativity and it has high electronegativity. So it attracts the what happens? They attract the electrons. When it is broken, they attract the electron to their side. Oxygen gets electronegative and this is electropositive. So what happens? The new atom that is added are basically what? They are electrophile, electron loving. They are nucleophile. So first this is added this, so they are nucleus loving. So nucleus is added to this because they have extra charge. They have negatively charged. So they love to attract nucleophile that have positive charge. So new electrophile, new nucleophile is going to add. So nucleophile is going to add on this aldehyde. And similarly, ketone also show nucleophile addition reaction because it is positive, it is electronegative. So new nucleophile is going to attach on this. Got it?
Yes, sir.
Yeah. Can write it. Written?
Yes, sir.
So first property I have shown that this slow nucleophilic addition reaction. Both aldehyde and ketone show nucleophilic addition reaction. Means nucleophiles are added. Addition reaction. Nucleophiles, nucleus loving, positive are added. So they show nucleophilic addition reaction. Second important thing is that the reactivity of aldehyde and ketone. Second is the reactivity of aldehyde and ketone. Second, right? How they are reactive. The reactivity of aldehyde and ketone. The reactivity of aldehyde and ketone. Okay, so first is electron releasing effect. Electron releasing effect. First is electron releasing effect. So in ketones, in case of ketones, when we talk about ketones, the carbonyl group, what is carbonyl group? That is CO group. CO. The carbonyl group in ketone is attached to two alkyl group. The carbonyl group is attached to two alkyl group, which are electron releasing in nature. Which are electron repelling or releasing. Electron releasing, we can say that, or electron repelling group. Repelling group. Electron repelling group. So they push the electrons towards the carbonyl group. So what happens? So they are negative. So they push the electron towards the oxygen group. So if you see that, 1 minute. So what I am going to say, this is your ketone. If ketone, we can see ketone. So this is carbonyl group. So these are electron releasing group. These are electron. They push the electron towards the carbon side. So here the carbon concentration electron is increased. So this electron shift to this side. It means that they convert into this. So they form, this is carbon positive, this is O, this is negative. They convert into this form. Okay. So more the alkyl group is attached. So so in such case they are very reactive. So they become reactive. If I give you a question, Nicholas, if I give you a question, you will write it, then I give you a question.
Yes, sir.
Yeah. So if I give you so you understand the concept, or I have to make you understand further? Because the question is going to be given on this concept only.
So could you just explain once again?
Okay. Come to the next part. So this is your carbonyl group, and this carbonyl group is attached with two electron releasing group. This is carbonyl, this alkyl group, this is alkyl. And alkyl group are electron releasing group. They are not electron loving. There are two types, electron loving group and electron hating group. So these are electron. This R is like C2H5, CSC. They have no electronegativity. So they do not attract electron. So they push the electron their electron towards the carbon side. So they push the electron to the carbon side. If they push the electron to the carbon side, so this carbon is negative charge. Then what happens is this negative charge also repels this bond. So electron get attached to that, and it has electronegativity. Oxygen is more electronegative than carbon. So they attract the electron towards itself. So they get easily converted into this point. When they get converted into carbon positive and carbon negative, oxygen negative. Now they are charged. Now they can easily get attracted by nucleophile and electrophile. So they get easily attracted as soon as they form the positive and negative charge. They get easily attracted by nucleophile. This is nucleophile, and they attract oxygen with positive charge. So as soon as they will form positive negative charge, they will get attracted by the electrophile and nucleophile, and that is why they are more reactive. Got it? More will be the electron releasing group. More will be the easily they will form positive and negative charge. Okay, got it?
Yes, sir.
Yes.
Okay.
Now, if I give a question, arrange the following carbonyl compound on the basis of reactivity. How will you arrange the following? Arrange the following carbonyl compound on the basis of reactivity. On the basis of decreasing reactivity. So this is your formaldehyde. Then this is first compound. This is your second compound. This is your acetaldehyde or aldehyde, and this is your ketone. So which is more reactive? This is the second compound. This is the third compound. Yes, arrange it.
And this the third one, like over here, like the double bond will break, right?
Yes.
Because of the
So
2 hours. So like that will be the most reactive, right?
yes. What you are saying there? Yes, Nikhil.
So like the third one, right? It'll be more reactive, right?
Why it will be more reactive?
So like over here, the double bond will break, right? And then like
Yes,
the
here the double bond
oh wait,
will
no,
break.
no. So then it'll become, so that'll be the like the least reactive because C has
Yes,
positive and O has negative charge.
yes, yes, yes. So they are
So like,
least
and
reactive.
after that, the second one, I mean, like the first one will be the most reactive because over
Yeah.
here we don't have like C positive and O negative. So like that'll be
Yes,
most
yes,
reactive.
yes, yes, yes. Good, you got it. So this will be the order of reactivity. So it is one will be the most reactive, one will be the most reactive, then followed by this and followed by third one. So this is the order of reactivity because the addition reaction is going to take place. Clear?
Yes, sir.
Okay. You have written it?
1 second, so almost done. 1 second.
Yeah.
Yes, sir.
So if we talk about if we compare aromatic aldehyde and ketone, if we talk about aromatic aldehyde and ketone, or aromatic aldehyde are less reactive than aldehyde, aliphatic aldehyde. Reactive than aliphatic aldehyde. Aromatic aldehyde are less reactive than aliphatic aldehyde. Why is this so? Like I am giving you a question. This is your aromatic aldehyde, and this is your aliphatic aldehyde. So this will be more reactive than aromatic aldehyde. Why? Just think less. Why is it so?
One second. So why they're less reactive? Right?
So this is because these are less reactive because they have resonating structure. They have resonating structure. Okay. They have resonating structure. Due to this resonating structure, the whole charge is distributed on the 6 carbon atom. The charges are distributed to the whole 6 carbon atom. So there are no positive negative charge to attract nucleophile or electrophile. That is why they are less susceptible to the nucleophilic or electrophilic attack. Okay. Whereas in aliphatic aldehyde there is no resonating structure is present. That is why they are more reactive. Got it? So due to presence of resonating structure in aromatic aldehyde, they are less reactive than aliphatic aldehyde. Less reactive than aliphatic aldehyde. Okay? Got it?
Yes, sir. Got it. Yeah.
Done? If we compare among LD, so next point is if we compare among aromatic ketones and aromatic aldehyde, then aromatic aldehyde are more reactive than aliphatic aromatic ketone. Got it?
Yes, sir.
So if we arrange them in the order of reactivity, so this is like this. So aromatic aldehyde will be more reactive than aromatic ketones, which will be more reactive than diphenyl ketone, and this is an aromatic alkyl. This will be more reactive than, so this will be more reactive. Sorry. So, and this will be more reactive than aromatic aldehyde. Okay, got it? Got it? This is the order of reactivity.
Yes, sir.
So we have to discuss the chemical reactivity. So what are the topics we are going to discuss in chemical reactivity? The topics can be discussed in chemical reactivity. So you know the funda, how it is reactive. So chemical reaction we are going to study under the topic. First, addition across carbonyl bond, addition across CO bond, replacement of carbonyl oxygen by other group, replacement of carbonyl oxygen by other group, then oxidation reaction, then reduction, then reaction with alkalis, reaction with alkali, and miscellaneous reaction. First, written. So first we will start going to discuss first is addition across CO bond. Okay, where each reaction is very much important. Each reaction is very much important. Okay. Addition across CO bond. Okay. So first, in this first we have Niklesh, can you hear me?
Yes, sir.
Yeah. So first is addition across CO bond. The first is addition of hydrogen cyanide. Addition of hydrogen cyanide. Addition of hydrogen cyanide. Addition of hydrogen cyanide. So this is your CO bond. This is carbonyl group. And this is hydrogen cyanide, HCl. So what happens? This double bond gets broken. This bonds get broken. So it will be C, C, and here Cn is get attracted. This is the addition of, and here this is O, and here H is going to attract. So the whole CN. So H is going to attract with oxygen and CN is going to attack this because it is electrophile. It is like this. This is converted in this form. So it gets positive charge and it gets negative charge. So now when CN gets broken, hydrogen is positive charge and CN is negative because of. So this hydrogen is going to attract O group and this CN is going to attract the carbon group. So it leads to the formation of this. Understand? Written? So this is known as cyanohydride.
Yes, sir.
This is cyanohydride. Cyanohydride. So this reaction proceeds with attack of addition of nucleophile. The reaction proceeds with addition of nucleophile because it is the slow process addition of nucleophile. Both the this is your electrophile. HCN is your electrophile and CN minus is a nucleophile because nucleus है. But out of these, the rate of reaction of this nucleophile is the slowest. The rate of attraction of this nucleophile is the slowest. That is why the reaction proceeds with. So the slowest step defines the slowest step of reaction defines the rate of reaction. You know that the slowest step determines the rate of reaction. Rate of reaction. The slowest step determines the rate of reaction. So this reaction is proceeded with addition of nucleophile. Got it? Got it?
Yes, sir.
These are the mechanisms of reaction. It is very important. So how it is proceeding? So this is your carbon. This is your oxygen. And oxygen, there are 1, 2, 3, 4, 5, 6. 3 pairs of electrons are there. Then now this is CN. This is your nucleophile because it is nucleus loving. So what happens under the effect of these? It is converted into the carbon is converted into like this. So this will be this. So this is your. So this is your CN is attached to this. So this will convert into oxygen. So one electron is get lost. So it is converted into positive charge. So now, sorry, this will convert into negative charge. So what happens now? The hydrogen is going to attract on this. So now hydrogen will come. Okay. So this is the intermediate. This is the intermediate. And this is your cyanohydride. This is your cyanohydride. Got it?
Yes, sir.
So if we write the reaction, so this is your CH3, C, or we can say that this is acetaldehyde. This is H, this is carbon, HCN. So it will be a, and this reaction basically performed under the action of hydrogen HCN dilute hydrochloric acid, HCl. Okay, and NaCN, sodium So hydrogen is this hydrogen cyanide is basically generated. This hydrogen cyanide is generated by reaction of dilute HCl with that of NaCN. So it we get hydrogen cyanide and your NaCl. So this reaction is generated by reaction of dilute. You will not write here because it is just so it is generated by reaction. You can write it here. This hydrogen cyanide is generated by reaction of dilute HCl and sodium cyanide. Dilute HCl and sodium cyanide. So what happens? This due to the reaction of this, what happens? It will get to like form CH3. Then it will be your OH. This is your CN, and this is your CN, and this is your H. So acetaldehyde, cyanohydride. So acetaldehyde, cyanohydride. Cyanohydride, you can say hydride. Okay. Got it?
Yes, sir.
So if there is ketone, this is H. This is your first example. If there is ketone, so this is your CH3 acetone. This is your acetaldehyde. This is acetaldehyde. And this is your acetone. That is your ketone. React with HCN. And what happens? So this will be CH3, C, then this is your CH3. It reacts with O, then your H, and it will form CN. So it will be your acetone cyanohydride. Acetone cyanohydride. Okay.
Yes, sir. So today, can we have a 1 hour class?
Okay. So we will start from. Okay, just I want to complete this topic. Okay.
Yes, sir. Yes, sir.
Yeah.
Yes, sir.
Okay. Written.
Yes, sir. 1 second, sir. 1 second.
Yeah.
So the last. Yes, sir.
Yeah. So what are the uses of cyanohydride? Uses of cyanohydride that we are preparing. Cyanohydride hydrins are used to prepare alpha hydroxy acid and amino alcohol or amino alcohol. And also they are used for preparation of alpha beta unsaturated acid. Okay. You got it?
Yes, sir.
Okay. So we will start our class from in Wednesday. Okay.
Yes, sir.
Yeah.
Thank you, sir. Bye, sir.
Bye.